Hey, no one talk, no, no one talk. No one talk. Quiet. Hey. Quiet. Next, read 13.
Okay, so it is y equals negative 4x to the negative
Negative 4x what?
To the negative 1.
Plus 3x to the
Negative 5. Thank you. Okay. One second. I gotta do something. Sorry. Read it one more time, Lexi. 13. Y equals
negative 4x to the first, negative 1. And then plus 3x to the negative 5.
Thank you. So I take the derivative of both sides. Okay, comment. Okay, some of you have already figured out, like people who were able to get through the homework, you've already figured out that with practice, it becomes legal and legitimate to start skipping steps. So for example, here's a, now I really think that you should ask me, you should just keep saying, is this legal to skip this step, and I'll let you know. Because I want to make sure you're not going to lose out on points on the written portion of the AP test. But for example, raise your hand, I'll pay you. How many in the room, at least on some of the problems, if not all, actually wrote this step where you were literally taking the derivative of both sides? Raise your hand. How many wrote that step? Give yourself 3 for doing that. Good work. Okay. From this day forward, if you don't have to write that step in order to get to the next step, you can skip this one. Okay? If it helps you to write it, you should keep writing it. My advice is always, look, I've never had a student who wrote a lot. How do I say this? It's like I've had many students who didn't write enough and they lost points. I've never had a student who wrote too much and lost points. You hear the difference? Yeah. So anyway, if you want to skip this one, it's okay. Sarah.
Are you saying not to write the top part or not to write the derivative?
Got it. I need you to write the problem for sure. Because if I'm helping you, I've got to see what the problem is. But if you decide to skip this step and just go to the application of the rules, that's okay. So, but don't skip it if it feels like I feel like I'm getting lost. So just keep writing it otherwise. I'll start paying tickets today. Somebody raise your hand and tell me what's the first rule we need to use. Let's go, Brady.
I did the add and subtract rule.
Perfect. So you're going to tell me exactly what to write.
So you do d parentheses negative 4 and negative 4x to the negative first over d of x plus d parentheses 3x to the negative fifth close parentheses over d of x.
Perfect. Feeling generous with all those texts yesterday, so 5 tickets for Brady. Okay, a couple of comments on parentheses. I really do need to have parentheses here because of the negative. Otherwise, it looks like D minus, which it isn't. Here, you don't have to have parentheses if you don't want. It's totally okay to write it how I did it. Questions? Please.
I do the next.
Oh, nice. Jeff's up. So tell me the next thing to write.
I did the power rule on the next one.
Comment. You really can't use, well, the power that I taught you, you can't use that.
I mean the not that one. Constant rule.
Yes.
Sorry.
Yes.
I just haven't memorized the names of them.
The names are the most important part, so no worries. Tell me what to write, Jeff.
And then so you would write, you'd put -1. Okay, wait, let me look at my thing. -4. Sorry.
Negative 4 times, wait, I did it right though, that's the thing.
Help him out.
Alright, so you're gonna do d over dx
Yeah.
with
Yeah.
x, so d of x, negative 1. Negative 1, yeah. And then you're gonna do plus d over dx 3. Sorry, 3x. Oh, you want to
Yeah, let's-
simplify that one too?
Let's do that one too.
Oh, so then you're gonna do, sorry, 3, so plus, negative, no, sorry, 3 d over dx, plus x to the negative.
It's my desire to be very generous and have to go with 3 tickets each, so
Only
you're right.
3?
Well, you know. Oh, no. I thought you would have said 3, wow, thank you. Okay, question. Pretty good?
So,
Oh, please. Oh, nice, Sarah's up, hold on a second. Jeff, please.
I do have a question. Could
Yeah.
you skip the constant rule?
For now, I wouldn't.
Okay.
Like, now everyone listen to this advice. For now, I wouldn't skip the constant rule. It's gonna mix you up if you do. Like, there's enough things coming down the road that, in my opinion, if you start skipping the constant rule, you'll start to feel mixed up. Just take, I know it's an extra line to write, just don't skip it yet. Let's go here to the Cal.
Can you skip the as-subtract rule?
What I think is legitimate to skip is this one, Mikkel. Don't write this step. If you want to go from this line to this line, that's perfectly fine. Does that make sense?
Yes.
Yeah, I would not try to go from this line clear to here.
Okay.
Just not yet. We're getting pretty close to being able to do that. Jeff?
So on the blue paper for the constant rule, it says c f prime of x. When do we apply that? Because like right now we're doing this one. Does that make sense? Like one
Agreed,
before.
yeah. That's on there for some future things, so don't
Okay.
worry about that yet. So, question? Anybody else? Sarah, you're up. Ah, too much, sorry. Okay. Oh, other thing, look at me, As I check your notation, I'm always looking to see if you're writing what's necessary for the AP test. If you want to stop writing dy dx on every line, that's okay. It was important for look at me. Hey, please remember, hey, it's very much, I'll use Braden as an analogy, since I played basketball with Braden. It's very much like what a basketball coach will do. You have to do certain things sometimes just to get used to the idea, to make sure you know you're doing it right, and then it kind of becomes second nature, you can stop kind of emphasizing it. So I get that it was kind of a pain on the first assignment. I get that. But it really does help you to know that that's what's happening. So from this point on, Deborah, if you just want to write equal, 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 that's fine. Now make sure, look, you've got to have one line that says dy dx though. Like you cannot do this. You can't say y equals, take the derivative of both sides, and the next line just says equal. That makes no sense. It's got to be y equals, and then dy dx equals, and then after that it's going to be equal, equal, equal. Do you understand what I meant, Kelsey?
So, like on our homework, we also have to say y equals and then f of x equals, and just like with my pad, I switched from all the y equals, is that okay?
Yeah, that's
And
fine.
my answer was the dy over dx.
That's totally fine.
For the AP test, is that okay?
You'll get used to eventually either just staying with y or staying with that prime, but for now what you're doing is won't cause any problems.
So question, so accidentally on the constant rule, I know what to do now, but I think what got me mixed up was I was doing d and then in parentheses negative 2x over dx instead of not taking out the constant.
You need to take the constant out.
Yeah, that's what I was doing.
Okay.
And I still got the right answer.
I gotta write down what you said.
Okay, okay, we'll go to negative, we'll go to 13.
This is 13, okay.
So I did d parentheses negative 4x to the negative 1 over dx.
All right, and then what did you do on the next line?
And then on the next line, I did d parentheses 3x to the negative.
That's a separate term. I get that. what did this become on the next line?
Oh, on the next line, it became -1 parentheses -4x to the -1 minus 1.
Ah, that's a problem.
That's wrong. Okay.
Okay, everyone look up here. 5 points for asking a really good question. Everyone look up. Everyone look up. Everyone look up. This has been a very common mistake over the years, but and what's happening is you're actually doing two things wrong, and it's leading to the correct answer. But trust me, it won't always work.
Okay.
Which means that if you like getting 50% on the test, it's fine, continue.
Yeah.
Okay, that's sarcasm, okay. Look, it's not, look at me, it's not -4x all to the -1. The only thing that's being raised to the -1 is the x. So you must use the constant rule. You must use the constant rule.
Okay.
Cool.
Cool, yeah.
Go, perfect. Everybody else? So don't do this, this is not correct.
Okay, cool.
But it's a really good question, that's why I gave you 5.
Awesome.
Is everyone good to hear? So now we can write the next line. I think it's Sarah, right? We get ready to write it, then somebody asks a question, so I lost track of who was going to do it. So Sarah, what do I write?
-4. And then,
Oh, so at this point, we're going to use the power rule. We're going to use the power rule.
and then parentheses, I put parentheses.
You have to, so I can.
And then -1, and then another parentheses.
That one's not required because everyone listen, hey, look. Everyone struggles a little bit with knowing how many parentheses to use. I need the -1 to have a parenthesis here because otherwise it's going to look like -4 minus 1. It's not, it's -4 times. Okay, the reason I don't have to have a parenthesis around the x is because it's just x alone. And so x alone, don't need an extra set of parentheses. But keep going.
And then -1 minus 1.
Keep talking.
And then the x over here.
Nicely done.
Boom.
And then the close of parentheses plus, and then another parentheses.
Not required, you start 3 start.
And then back in.
Yes.
-5 x, -5 minus 1. Dx over here.
No, perfect, Sarah. 5 tickets, hold on. Chad?
For the dx over dx, do you like have to write that, or if you wrote +0, would that work?
Oh, listen to Chad.
Or
If I-
+1, I guess.
Yeah, listen close.
Times
It's
one,
okay.
times whatever.
Listen close. 5 ticket question. Listen close. Listen close. Okay, don't, yeah, a little sarcasm. First of all, don't write plus anything because there's no plus.
Yeah,
Very
I
nice.
my bad.
Next thing. I gotta see your eyes on this one, everybody. I don't want to, Derek's gotta look up. Everybody look up, sorry. Everybody look up. Everybody, not trying to sing with you, sorry. Okay, everyone in the room, unless you want to be like extremely confused in about 3 class periods,
Oh.
you must write dx over dx. This is when you're just gonna have to trust me. If you will follow the habit, it'll be just like basketball. In the game, things will work perfect. But you gotta get the habit down. If you don't follow the habit, it's gonna cause trouble.
Wait, why is it dx over dx and not d mod over dx?
Oh, that one's a different answer. It's a really good question. The power rule says this, Landon. We use the power rule whenever we have some expression raised to a power.
Yeah.
And according to the rule, it's number multiplied by the expression, new exponent, multiplied by a derivative of just the expression. So in this particular use of the power rule, you're going to answer my questions here. Okay, here we are, we're going to use the power rule. You tell me what's the power in this case? What's the expression that is raised to that power?
dx over dx.
No. What this says is d over dx of x to the minus 1.
Oh, you're right.
Just like this says d over dx of something to the n. So to use the power rule, you've got to identify we have a power, we have an expression being raised to that power. So once again, what's the power?
-1.
Good. What's the expression that is being raised to the negative 1?
It would be just the x, I guess.
Just the x, I guess is correct. You good there?
Yeah.
Okay, so when you use the rule, look, you write down the negative 1
Okay, yeah.
multiplied by whatever was being raised to the power. So what's going to go here in our case?
Would that just be x?
Just the x. 1, sorry, this will become negative 1 minus 1. Derivative, so d over dx of just the expression that was raised to the power, so it goes here,
Which is x.
which is x. Did that make sense?
Yes.
That's why it's dx over dx. Over here, look, the reason it's dy over dx here is because when we started the problem, we literally applied the derivative operator to this. So it became dy over dx. Did that make sense? Is that your question? 5 tickets. Let's go here, Sarah.
I'm sort of confused, so it's really a little bit better, not on like the last one, but when we use the constant rule to get to like the negative 4.
Do this, Sarah. Just tell me from which line to which line.
Okay, from 2 to 3.
Keep talking now.
So, and then 3 to 4. So I understand like the power rule, but I just don't get how, like why we use the constant one to get to 2 and 3 instead of just the power rule for 2 and 4.
Got it. Let me lead you through some questions. I think you'll see it. Now you just keep asking. Okay? Right here, okay, if we're going to use the power rule, we have to identify that there is some expression being raised to a power.
Oh, so the power is going to be outside the parentheses?
The parentheses aren't the important part. So you're close though, stay with me. The parentheses aren't the important part. We've got to have some expression being raised to a power. So in this case, do we have anything being raised to a power?
With the x to the negative 1.
Good. So negative 1 is the power, and what is being raised to the negative 1? Just the x. Okay, to use the power rule, that's all we can have. So the negative 4 is in the way. We've got to get rid of the negative 4 first. So that's what we use the constant rule for, is to get rid of the negative 4. Now we can use the power rule because all we have is some expression being raised to a power.
So we kind of just ignore it, do like, okay, sorry, it just looks different in the rule because of the negative 4, so do you just ignore that?
We didn't ignore it. What we did was this. Keep talking, it's great.
So we just put that on the outside of the parentheses?
Right, because that's what the constant rule says you can do.
Okay.
Listen close to the words. The constant rule says that anytime you have a constant multiplied by some function, if you like, you do not have to leave the constant that's the multiplier within the derivative operator. It can come out of the derivative operator. It has nothing to do with these parentheses. It's just it can move out of the derivative operator like we did.
And then to use the power rule, you just can't have a constant?
Yeah, you can't have a constant time expression to a number. That's not what the power rule says. The power rule says only expression to a number. It doesn't allow for the extra constant.
So we use the constant rule to get rid of the constant and the power rule.
To handle the rest of it. Did that help?
Yeah.
Boom.
5 tickets. Elliot.
3, when you do the constant, can you also write it as negative 4 d over dx and then x to negative 1, like to the side of it, like how negative 4 is to the side?
Tell me exactly what to write here so I can
So
tell you.
negative 4 and then just d over dx and then x to the negative 1.
Like that?
Yeah.
Yeah,
Can you
that's
write it
fine.
like that?
They mean the same thing.
Okay.
Good question. 5 tickets. Chad.
Does the d over, or dx over dx have to be in the parentheses, or does that not really matter?
Have it in parentheses.
I mean, just be
No,
sure.
that part doesn't really matter. For example, this is a good one.
I
5
was
tickets.
writing it, but then I realized I was writing it outside the parentheses.
I'm going to write it a different way and see if this is what you meant. Here's the key idea, everyone. The key idea is you have to make sure you communicate what's being multiplied versus what's being added. So here I've got to have some sort of parentheses that distinguish between
Yeah.
these two. So you could write it like this if you want.
Yeah.
That's legal.
That's almost really bad.
Is that kind of what you wrote?
I put the parentheses around the X part of it, but.
No worries, so tell me exactly what you wrote here.
So I wrote, this is 13, right?
Uh-huh.
I wrote 3, parentheses, -5, parentheses, X. Or actually, I put it around the X, like facing, the parentheses facing the other way. Like
So-
X inside of parentheses.
Here's how you say it.
Oh, yeah.
Say 3, open parenthesis, now what?
Okay, open parentheses 5,
-5.
-5, open parentheses X, close parentheses, exponent -5 minus 1, close parentheses, and then that's our dx over dx.
That's legal.
Okay.
Nothing wrong with that. Is that your question?
Yeah.
After the dx and the dx?
What's that?
Can you end the final parentheses after the dx? and the
Yes,
dx?
as well, also legal. Other question? Please, sir.
Can you write the rule that you use, like, in the line? Like, in between 3 and 4, can you guys write?
I can tell you the names, it's a little hard to write the actual rules. if that's-
Yeah, just write the
Sure.
name.
So what we did, first step was just take derivative of both sides.
Yeah.
From here to here, this is kind of what you want, right?
Yeah.
This is the add subtract rule. From here to here, constant rule. From here to here, power rule, and then we're done. Okay. Is that what you need? Yeah. Cool. Anybody else? 5 per sword, good comment. You good? Oh, please.
Can we do that on the AP test to just kind of keep us in order? Like, I found like.
This one like
that-
this?
Yeah, I found doing that helped, but would we get docked? if we did that?
You won't get docked, no,
Okay.
no way, no.
How to say
For visiting fun. And
So on this one, like how are we done on this one?
Oh, on all of these problems, the way you know you are finished is, watch this, 1 second, ladies, sorry. The operator, initially, the operator was working on the entire function. You see that there? On the next step, we split it up. So the operator's working on each half of the function. We then did what I was saying to Sarah. We said, the constant rule tells me that I don't have to keep the multiplying constant within the derivative operator. The multiplying constant has no effect on the result other than it doesn't go away. So I move it outside of the derivative operator. Do you see that? So now the derivative operator is only working on these pieces. When we use the power rule, the derivative operator is only working on x. So think of it as this way. The derivative operator kind of worked its way through the entire function. It worked on everything. You know you're finished when it's done working on everything. Because all we have left is 1 and 1. So the derivative operator has disappeared. It's not even present.
But in the one above that, like, they're both dx or dx.
All I did here from here to here, people were asking questions about what is the appropriate way to use parentheses. We just showed another example. This line is not required. So the very next line would look like this. I'm not sure if I've answered your question, Hannah, so don't stop if I haven't. I know I'm finished because it doesn't say to do ddx of anything. That's how you know you're finished.
It's for.
Curses.
Class, you know? All right, please, Jackson.
Does it matter if we have it to the x to the -2nd or if we put it over x to the?
Yeah, that's what I was.
5-ticket question. If it's the written portion of the AP test, it doesn't matter at all. Either way is correct. If it's multiple choice, you have to be able to find your answer. So you have to remember the property that you're asking about. But otherwise, it doesn't matter. Is that what you meant, Jackson?
Yeah.
Perfect.
Willow property is that one. Because I just kind of, oops.
Say again.
What property is that one of these?
It's not, no, this isn't on the blue sheet. This is just a property of algebra.
Oh, I knew that then.
You knew that.
Like a special.
Okay, so Mark, there's sometimes on the answers it keeps something you refer to in the parentheses, and other times the number distributes through. Does that make sense? Like, how would you know when to distinguish?
Really good question. Hold on. Be quiet, please. Does anyone have a question here? You're going to flip to a different page to answer Oakley's question. Oakley, read an answer that kind of shows what you're asking.
Oh, okay.
I'll write down the answer and I'll tell you what you're.
So, answer to 45, negative 36x squared, parentheses, negative 3x cubed minus 5, close parentheses, the third power.
Okay, everyone should watch this. It's a very common error. So tell me your question again.
So I just didn't know if I ever distributed.
Got it. Okay, here's why you'll never distribute here. Order of operations requires that we take care of the exponent first, which means we would have to take literally this, dy over dx. I think the homework is hard, trying to do this.
So it's just to make it easier.
Yeah, don't do it. Feel free. Feel free if you feel so inclined, but you literally have to multiply this times this times this, which means you have to FOIL these two and get a result, and then distribute it all with this, and then go like this. And then, yeah, don't ever do
So it's
that.
like the same thing, keeping like a square root instead of actually applying the square root.
In a sense. The other answer is this. Hey, hi, Oakley, good question. The other answer is, in Unit 3, we're going to want to have the derivative factored. So we don't want to go unfactoring the derivative, which is what this is doing. We want to leave it factored. This is unfactoring it, so we don't want to do that. Please.
In theory, like not, but like in theory, couldn't you like after you find the derivative, find the next derivative, like just keep going?
Yes, forever. And look up, look up, look up. In the problems that we are practicing, like on homework last night, that would be a bit, like, just painful. Because the derivative is not a nice, easy function to deal with. On the AP test, they will test you on that idea. One second, Brittany. They will test you on the idea of finding f prime and then finding f double prime. But it will be in situations that aren't nearly as nasty as this. So yes, the idea you must remember, because you're going to have to use it. Read the name, Brittany.
Brenna, Ellie, and Chance.
All three duration.
Oh, dang it.
Brenna, Ellie, and Chance.
Chance, what is it, dude?
Yeah, please, sir.
So then once we like solve the derivative and then we have an equation, is that the function that like if you look at the points, that will give you the answers of the slope?
Chance.
What's the jump?
Chance is over here.
Jeez, what's that?
Perfect, perfect, perfect.
Hey, Brittany.
Hey. 5-ticket question for Sarah. Listen. Don't miss this fact. Hey, don't miss this fact. Listen. You said it perfectly, Sarah. We started with some function, okay? If we were to use some computer software to graph this function, we'd see some sort of curve, a bunch of points. If you went to any of those points, found an x-coordinate, plug that x into this formula will tell you the tangent slope at that point. Exactly what we found. Perfect.
So they would find instantaneous. So that's
Perfect.
cool.
Perfect.
Whoa.
That's exactly what this is. Does that make sense?
Yeah.
Perfect. Question. Okay, I want to do a couple of examples from tonight's homework. Now, if it feels like you've got it down cold and you just want to kind of get started on tonight's homework, I'm going to give you the homework in class today, so that's a little different. I'll text it out as well, but here's the problem for tonight.
There was not the extra tickets for getting them right.
Here, boys.
It was
Chad. He was wondering about the
tickets. Yeah, what about the tickets for like doing this?
They're coming, they're coming.
Sick. I need them. That's why I wanted.
Still on my list.
Can I take a picture of that really quick?
This?
Yes.
Yes, hold on.
Everything you would not do less.
No.
Oh, actually, yeah, sure.
Yeah, I felt like last night was a really good start at getting down the pattern. So tonight the number of problems is significantly less.
Oh, yeah. I said for some 30 things.
That is to give enough practice that you really get the hang of it without feeling too tedious. No, that's just tonight.
Let's do
Do you want me to read it?
Yeah.
Okay, here we go. You're going to do 3, 4, 5, 6, 7, 8, 11, 12, 20, 21, 23, 24, 27, 39, 40, 51, and 56. Okay. One other comment, I think. Left my brain, I don't know. Okay. It doesn't really matter, listen. It doesn't really matter which example I do, because once you pick up on the pattern of how to use the rules, you're just using different rules. So I'm willing to do any problem from the assigned homework. You simply raise your hand and, oh, hey, you got a question long ago and I never got back to you.
That's okay.
Sure? Sorry about that.
Oh.
Hey, somebody pick one from the homework. I don't care which one you want. We probably won't do the whole problem because after a while it will start to feel like last night's homework. But we'll at least get you started and kind of get the hang of it.
So is it just a little bit different, just using a different?
Just different rules.
Different rules, so different needs.
Yes, it's really not, if you understand the overall pattern, it's not different at all.
Oh, really?
It's just a different rule.
Oh, okay.
We'll practice a little. Let's.
I have a question on the adding factor. So even if it's like a minus, there's a sort of minus instead of still achieve less than.
Got it. Got it. Hey, everyone look up. She's asking about the add subtract rule, and it's worth 5 tickets, Lexi. It's a very good question. You can actually choose. So for example, I think what you're asking me is this. If we had a problem like so, I'm just making one up, but I think it's what you're describing. And we take the derivative of both sides. I can write, so I, do this. Okay, at this point, Lexi, you have 2 choices. You may either write minus, like so, or you can write, this would be the same, of course. And they really are the same thing. There's no difference. Now, my advice is probably to get used to this one, because it's going to be more like what you'll see time and time and time and time again throughout the year. So if you get used to this, you're probably ahead. They are the same thing. Is that your question? Is there a homework problem you'd like me to do? 3?
I was just
3, 7.
Oh, I see.
Be quiet, please. No one talking. No one talking. No one talking. So take the derivative of both sides. Now this was kind of Kelsey's question. You can just do this, Kelsey. Taking the derivative of f creates f prime. So if you'd like, you can just write f prime. It's a lot easier.
And that means the same as dy over dx. Okay.
Oh. So then I take the derivative of the other side. F prime, 1 second. Please, Brady.
You use the inverse cosine rule.
Perfect. Tell me exactly what to write.
So you do -1 d. Wait, next to the -1, don't you?
I'd probably do over first.
Oh, over d of x. Oh no, over.
Square root 1.
Yeah, square root. Thanks, Jeff. Square root 1 minus parentheses 5x to the 5th squared.
Say close parenthesis.
Close parentheses squared. And then d of x. D over d of x.
D over dx of what?
D. Oh, it's shoot 5x. 5x.
There we go.
That's true.
You don't do cosine negative.
Look at the rule. Look at the rule. Look at the rule.
Oh, you do cosine.
The rule says this. Look. The rule says if you have the derivative
So that's
of the inverse cosine of some expression, that is the same thing as 1 over negative square root 1 minus the expression squared multiplied by d over dx of the expression. Nowhere in here does it reference cosine.
Gotcha.
You see what I'm saying?
Yeah.
Does that make sense?
Yeah.
Does the line go all the way across?
Which line?
The division line from like, on here, it's like continuous.
Oh, it's either way. Yeah, it's the same. You don't want to really, if I wrote it, I gotta see what I wrote. Oh, that's not really typed correctly. Sarah noticed something really good. Hey, look. She noticed that when it got typed up, it shows the line going all the way. You won't really write it that way usually. So Sarah, we usually think of this as one big chunk being multiplied by this. Mathematically, it's not really wrong. It's just not really written that way. Does that answer your question, Sarah? Hannah?
So are you just supposed to put like the factors in your parentheses? Like, is that how you know what to put inside there?
Here's how you know. Everyone listen. Hey, the way you know is when you read the expression, what you're reading is d over dx of inverse cosine of some function, some expression, something. Okay? This something is the same as this something is the same as this something. So the parentheses are meant to represent that these are all the same. So I identified it initially, but I've got the inverse cosine of what? Tell me. 5x to the 5th. So when I apply the rule, it becomes -1 over 1 minus that stuff, 5x to the 5th, squared, d over dx of that same stuff. Is that your question? That's good. Anyone else? Awesome. Need to keep going. So I say f prime of x, -1, square root, 1 minus 5x to the 5th, all squared. We need to take care of this now. Somebody help me, please.
So then that's, the constant is dot, or just dx.
There we go. Questions? Going? Oh. Right.
Oh, no, well, I sort of had a question.
Oh, please.
Like for the tangent rule, it doesn't matter which one you use, because I know.
Oh, got it, yes, good question, hold on. Hold that for 1 second, just make sure you ask it again. It's really good, 5 seconds. Somebody, what comes next? Go. Tell me what to write.
5.
Now here we do need a parentheses, otherwise it looks like we're writing 55, so.
Parentheses, 5, x,
No, it doesn't.
5 minus 1, and then dx over dx.
Nicely done. 5 tickets for Maddie. Please.
You write the.
I want you to help me though. If you're wrong, it doesn't matter. The act of like trying to remember it helps you remember it better. That's why I want you to say it. So from here to here, we simply took the derivative of both sides. So what's this one sort of?
The inverse of.
Perfect, inverse cosine.
Yep.
And then from here to here,
That's the constant.
perfect. And then from here to here,
So it's power.
perfect. Not so perfect. Okay, look here, everyone. Look here. Okay, it's critical that you can do the following. Critical. You all know my stupid slogan. If you fail to factor, plan on failing. Okay.
Wow.
This is in factored form. And it's really a rational function, meaning it has a numerator and denominator, and it's in factored form. Got it? So you have to be you have to be able to identify the numerator factors and the denominator factors. So someone who would like 5 tickets, this is just going to become 1, so we won't worry about that. Please raise your hand and tell me what are the factors of the numerator, what are the factors of the denominator. Brent, ready, start.
So the numerator would be -1,
So we got -1.
5, and then would it be 5x to the 4th?
Those are separate factors.
Okay, so 5 and then x to the 4th.
Perfect. 5 and then x to the 4th. Those are separate factors. It's kind of what Jeff's mistake was earlier. No worries, but those are separate factors. Okay, good? How about the denominator, Braden? What are the factors of the denominator?
Basically everything in that square root.
Perfect. There's only one factor in the denominator, it's just a big old factor. So 5 tickets. So what we do is we simply combine the factors in the numerator that are easily combined, and then the denominator is nothing we can do. So you write f prime of x. Someone who'd like 5 tickets, what factors can be easily combined in the numerator? Let's go. Try to get somebody new this time. Ellie, go ahead.
The 5 and the 5 make 25, and then I make 1 thing, x to the 4.
Nicely done. 5 tickets. Jeff, please.
I can bother.
We'll just leave it like this.
No.
No, don't leave it.
In the answer.
Oh, they don't leave it?
They don't.
They actually
Oh.
square the
Oh, Jeff is gonna get 5 tickets for something there.
noise.
Can we leave it like that though, or do we have to?
On the, same as before, on the written portion of the test, totally valid. Totally. In fact, this is valid. Like, you want to say this is 1, but other than that, they'll give you full credit on the written portion. On the multiple choice, you gotta be able to pick your answer.
So with the dx over dx, they want us to write 1.
What they really want you to do is recognize that this is the same as 1, and then not write it anymore.
Oh.
That's what they really want. And I won't deceive you, Sarah. We will eventually stop writing this. Just please don't yet. It really will cause all kinds of havoc in about 3 days. So don't stop writing it yet. I know it's a little tedious, but it will develop the right habit. And in 3 days, you go, oh, yeah, I get it now. It's so much easier. I don't make this mistake. It's a mistake that happens. It happened a lot years ago. Until I started emphasizing, always write dx over dx, and no one ever makes this mistake I'm warning you about. So.
I totally.
Oh, hold on a second, Jeff. So we got 25 x to the 4th. Okay, I have a question for you. If you answer the question correctly, you get the 5 tickets. If you do not, you get 1 ticket.
Oh, I think you
Are
said
you ready?
negative that.
Oh no, I don't take things away. Are you ready? Good, pressure's on. Okay. So some people, when they answer this question, they simply say, they go like this. They go, 5 times 2 is 10, so they write 5x, don't do anything yet. They say 5x to the 10. Right? That's one possible answer. Right? Other people will do this. They'll say, no, they'll think 5 plus 2 is 7. They'll write 5x to the 7. Okay? Other people will say, and here's where I can't help but be sarcastic. Other people will do the right thing. They'll say, no, what does it mean to square something? It means to multiply by itself. So they'll write 5x to the 5th times 5x to the 5th. And then they'll say, oh, I just have a bunch of factors here. So you tell me, Jeff, what are the factors of this expression?
5x to the 5th. 5 and 5. 5. So 5 is not the same with 5x to the 5th, right? So it'd be 5 and then x to the 5th. And then 5.
There you go.
And then x to the 5th.
Yes.
He's got it.
Good. So what factors of those, because there's 4 factors there, which of those easily combine? Which of these
5, the 5s and 5.
combine to make?
25.
And
the x to the 5th and x to the 5th combined to make x to the 10th.
this is the correct answer.
So I get all 5?
Yes.
5.
So that really should have been 25x to the 10. This is how you should do it.
Okay.
These are both, this was yuck. Don't do that. Okay. Questions? Please, Ellie.
Okay, wait, I think I know why. Okay, so you can't combine 1 minus 25x to the 10, even though the 25 is a separate term to the x to the 10th. Is it because those two are multiplying and 1 minus that?
What they told you in algebra long ago is you can only combine like terms.
Okay.
They don't add. Anybody else, please?
How come when you multiply the 5x to the 5th and the 5? Oh, wait, actually, no.
Good question. No, hey, listen to this one. 5 tickets for Sarah. I'm very serious. One of the best ways to learn is you just keep confirming what you're thinking. And what you just did confirmed it without me having to say anything. It's perfect. Just keep doing that. Good work. Anybody else? Okay. Oh, great. So I'm trying to figure out what to do with this. And I've got some expression to a power. So it's the power to get five here. So use the power. Maddie.
Do you have to write it with the 25 with the root and the 5x to the 5th? You're again.
You're okay. On the written portion of the AP test, everyone knows. On the written portion of the AP test, this is fun. However, on the multiple choice portion, I have seen them do this.
Was it better if a written portion was all the way out?
No, written's better to stop.
Okay.
Because you're like, hey, I've done enough. If I make a mistake, I'll shoot myself in the foot. I don't want to do that, so might as well stop. So. But on the multiple choice, you got to be pretty simple. Okay, when you come around the room now and check your homework and pay, listen closely to how I pay. Look at me. Go look at my eyes. Here's how we're going to pay.